Did you log in?
Tractor, did I miss something?
Okay. And you select whatever you. Yeah. Huh?
I don't know why I can't enter the directory. Then I'll get my name.
Yeah, it is. It should be already here, right?
Yes.
Yes. Oh, yes. Absolutely. 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 So if you do see the things, it is kind of a program for the labs, not for the class. In the class, we are doing a little bit different things, but there are practical skills that we are covering in class, and in approximately 3 labs we will cover all of them, and in about 3-4 weeks there will be one day during the class time when everyone will present a little bit. And please, during this meeting, think what you like at most, and if you have more than one wish, put it there. I will try to avoid conflicts, and then we will select only one piece of paper, make it circulate, and do sign up so that we cover all things. Since amount of attendees of the class is smaller than lucky number 13, you can select for like 2 or 3, and we will then optimize. So when we were here last time, we did a little bit of Linux and environment and basic Linux commands, right? And you know how to find it in Google, or logging in and do man manual and then on any command and just practice them. There is one thing more that we didn't do last time, but it should work automatically, so-called X connection, when in addition to typed commands like you are chatting with a computer, there are commands that enable graphical information and mouse operation. It's called X connection. And we didn't cover uploading and downloading files, but we may do it today. Those are cool things, but I'll skip for today. Probably we'll go to this like number 5, 6, and 7 as much as possible, and when time, if there will be time, we'll go for more things. So in your homework that you gloriously and successfully accomplished, you are drawing atomistic models of like hydrogen molecule, right? Putting the coordinates. And then you were adding more vectors for position of electrons, right? But since electrons are clouds, they're like quantum particles distributed in space, in practical things, we do not set up position of electron. It will be a little crazy idea. So when you do, some of you are doing molecular mechanics, molecular dynamics of big systems, you start with models that do specify positions of elements, atoms, right? So if you have only H2 molecule, like two nucleus, how can you do it? What is the natural way to specify it. And we are doing baby steps. We will ramp up very quickly, so do not look skeptical if it is too simple. So if there are two hydrogens and we want to specify all informations about this nucleus to feed it into like computational chemistry package, what do you do? Just give some ideas. You open a specific software, you just click and draw molecule, right? It's mostly natural, like in kindergarten. Same as we did here. But if we do not have graphical terminal, if you live like 40 years ago or 50 years ago, or if we actually want to provide some information for computation, how do we communicate position of something? Like what is this vector?
Vectors and matrices.
Huh?
Define them by vectors and matrices.
Vector. And what is vector in three-dimensional space? How many components?
3.
So if we want to be specific about molecular model, we need to like give 3 numbers for each atom, and we can make a table of these coordinates, right? So for the practical side of computational chemistry, it is an important. It is very simple. We can give up all our college education, graduate education, and even high school education, go back into kindergarten and draw molecules or set up coordinates. It's rather simple procedure, but without doing it in like confident way, the rest of things are not possible. So suppose, how can we do it without any computer and without any mouse, any graphical tool? What is the approximate distance between two hydrogens, atoms in hydrogen molecule? In any units, how far are they? Huh? How far? What is the distance? Around 1 angstrom. Yes, it's perfect. It's very good guess. It's maybe 0.9 something, but starting from 1 is a good guess. And if you select angstroms as units, then we can define define system of coordinates, and we want to minimize amount of information here. We can move the system of the origin of system of coordinates in such way so that most of these numbers will be zeros. So if we can move this origin from here to combine it with position of one of the hydrogens, right? Then you'll put 0, 0, 0 in all of the coordinates of the first atom. And then we can select that first axis will be x, and then y and z will be going elsewhere, but the second hydrogen will be laying on the same axis. Hey, how are you? So, according to your hypothesis, the offset of the second hydrogen along x-axis will be 1, right? So we need to make this table 0, 0, 1, 0, 0, and it will be our molecular model of hydrogen. Please protest now or stay silent forever. If you do not like this idea. I'm joking, but if you are not comfortable with this idea, please discuss it. We can check that everyone is happy with it. So it's quite basic, right?
We are hiding the position on the x-axis.
We are providing, so it is our input as humans. We use our scientific engineering chemical intuition to set up initial coordinates of each ion. We record it as a set of coordinates, and then we need to save it in a computer, right? So if we really want to model this H2 molecule, which is a little bit silly, there are not many scientific puzzles in it, but we should start from something simple. We may create file with these coordinates, and you know the Linux VI command to edit files, right? So also probably we need to specify which type of atom. For in each line we have set of coordinates, and we can put like hydrogen, hydrogen, first hydrogen 000, second hydrogen 100 or 0.900. So what I'm inviting you to do is just open VI editor and do this. And it is a little silly exercise. We will not do it every time. It's just to get a flavor of 1970 computation. I'm not so old. I was not born by this time, but I've heard people were doing it without mouse. So I'm calling file maybe H2XYZ, typing I for insert mode, and I will try to put like comment what it is. Then number of atoms, and then I will write first hydrogen has position 0, 0, 0. Second hydrogen has position 0.900. And to save, I am typing escape column write quit.
So you put type number 2 on the second line?
Yes, total number of atoms.
Oh,
ESC, escape, then column, and then letters, lowercase, right, quit, and then enter. And then if I'm checking what is inside my file, there will be same thing. So let me walk around and see that you're feeling happy with this little silly exercise. So I for insert mode. H000 H100 escape right quit and more. Okay. Like that. Steven.
Yes.
Okay. I for insert, some comment, number of atoms, H000, H100, escape, shift colon, right quit, more, just there. My pleasure. Yeah. And then escape.
W key.
Yeah. So I for insert mode, like just I, and then start typing.
Okay, thank you.
My pleasure.
I just arrived. I was.
Let me type. I will.
This
Photo kill Indies U North Dakota.
yeah. Yes, I forgot the name. Yesterday I didn't write the homework.
That's okay. You can give it to me right now, or next time you can just scan it with cell phone and send by email.
Yes.
That's fine.
But
It's okay. It's okay.
Is it still going to be 11 or tomorrow?
Tomorrow 11 years.
Because I have another class.
I understand. I was trying to match wishes of everyone. And
Yes, I know. When I was watching the video, I didn't get to the part where this was, so I didn't.
don't worry. It's not late. It's not late. It's fine.
So when I do VI and then I create, I can
And then
create
you
new
need
file?
I. Yes, I for insert mode. Yes.
Yes, I know. So I just coordinates
Uh-huh.
for H2 and then 2.
My pleasure. Okay.
Oh yeah,
Okay. Okay. Sorry for two simple things.
Yeah, we used that before.
Okay, escape. Escape.
this one.
WQ, enter. Then more. MVH2 H2.xyz VI.
Oh, is it a point?
Uh-huh. Okay. Yeah, very good.
you should do those.
No. I'll tell what to do. Okay. I think we do not need this command. So we are going slowly but surely, but we will speed up during today's meeting. For doing calculations, of course, we need molecules much bigger than that, and there will be tools to do it. For computation, the software does not need graphical information, but us humans prefer graphical information just to see that we are not doing mistakes. And there is a variety of software that converts this text information into graphical form. And more than that, there is a software that converts human motion, like mouse clicks, into text data. So if we want to check that what we have created makes sense, one may try to run one of these programs that visualizes the drawing. And before I invite you to repeat the steps, I want you all to avoid my mistakes. So when I was typing, right now I do not see what is the what was the error, but the format and lack of some tabs did it not quite readable. Let's do it once again. H2 test. So I have borrowed a little bit different format, but let's do a little of clean experiment. Okay, good. So
You put a minus, the error.
huh?
The error was just because of this minus.
No, I think because I didn't put there was not sufficient spaces and digital.
Number of digits.
Yep, number of digits. So what I did, let me close it and do it over. So I am doing this command. So this is a little script, one of the simplest visualization commands that you can install forever on your personal computers. It's like JavaScript that will work on any platform, Linux, Windows, Mac. And it is just passed to its location on this computer. And then if you type H2A, and I suggest you put this symbol ampersand at the end. We will practice a little bit of patience, and then there should be appearance of the software, and it will show the molecules that you are drawing, or like drawing with little corrections. So and then you can select this rotation tool and just click and see that you can look on it and see how it looks like. So let me walk around and see that you got to this point. I'm going to just play a little bit. Okay. When you were okay, no, you did things correct.
Please show
Okay.
peace and speed.
No, I did the same.
Okay.
Wait. See, and it appears here. You can play with it. Yes.
That file was by your creation.
It is the same. I just slightly changed the format.
I'm not sure.
No. The PowerPoint is from previous years when computer systems were a little bit different. Okay.
What else did you do?
You got it? Excellent. Yeah. So there is a little little trick that we can we will repeat later with at much more updated level. So there is a measure distance. So you can click on the first atom, second atom, and add to measurement list. And it will show what is the distance, what you put inside your table. I'll quickly walk around to see that you are. Yeah, good. Measure. It's not symbol but text in the menu. Here, measure.
Oh, wow.
Distance, and then click on first atom, second atom, and then add to measurement list. Yes. One, two. Okay. Oh, you did add to measurement list. Okay. Measure distance. 1, 2, and okay. Yes.
What is the significance of that?
The ampersand symbol at the end tells that you still can type something after that. If you do not put the symbol, it will block you from typing any other commands in this window until you close the application. And now you are in the multitasking regime. Display, item style, item labels, atomic symbols. So you can put that it is hydrogens or atom numbers. So first, second atom. It's a little bit silly, and we will get much better than that. But there will be this tool is free, available to everyone, and if you do not need to build models, you can use it anytime. And this little X, red X, means delete. If you want to delete an atom, you can click on it, and it's not a molecule anymore. It's atomic hydrogen. But I don't want to save it. I'll better reopen the molecule. And then there is a very simplified way to save in different format, which we will cover later. So there are the format with Cartesian projections is most simple, but there were a lot of ambitious scientists and programmers since like 1970. Each of them wanted to create his or her own program and his or her own format. And there are about 100 formats of saving this information, which differs by like symbols. It still has the coordinates, but it has a little bit different language, and we will cover it in a lot of details later. So, if you are very skilled, intuitive chemist, you can create any molecule by just putting numbers. But it is not very efficient. It's better to do drawing, like chemists do on blackboard, just drawing benzene cycles and more complicated molecules. We are not covering any actual computation today, but we are focusing on model building. So let me try to close this one and try to type this command and see what happens. GVIEW. So if you are not looking into solid state materials, if you're not looking into engineering problems, if you're only focusing on chemistry of molecules and biomolecules, you do not need anything else than this tool. Well, I'm a little bit exaggerating, but this tool is quite universal. So this tool is the shell that helps to create models, to analyze models if they were computed or provided by your colleagues, and to launch computations. This shell is not doing computations itself, but it serves like a translator, passing on your wishes to a program that does electronic structure and molecular dynamics. For today, our goal, our wish is just to replace this boring procedure of typing in coordinates just by drawing things. So build models. And some of you will select portions of the software as subjects of your presentations in whatever, 3-4 weeks. I will try my best, but with your fresh young brains, you can find a lot online. You can find some materials in the book that goes over the rows. What it is now? Yep. So it is basically a book devoted to the software. And there are some website of the authors of this paper, and there are some help information. Where to start from? Probably with periodic table. So
so it can generate the structure, and also it can minimize the structure
yes.
and then get the coordinates.
Yes. I want to give a little warning. You may get, some of you may get immediately super excited and decided that you are masters of universe and can do everything, which is not far from the truth, but this piece of software right now, we are accessing it on a small server, a little bit bigger than that, not on a true supercomputer. So it is optimal to use only to build models, and very soon we will be uploading the tasks onto true supercomputers, where you can in short time describe properties of rather big models. If you are trying to, you can look around and click on all menus, try different things, but take into account that all of us are logged into one small server and competing with each other for resources, and it is not a ultimate computer power. So it's mostly for editing and creating models. So the very first mouse button is this 6C is periodic table. So you may, if you want to create just hydrogen molecule, you select hydrogen and just click, and it is already there, right? And of course, our interests will be a little bit bigger than hydrogen atom. So you can erase it, and one can start with what is the next by level of complexity, maybe methane molecule. You can create it in one click. So please try to play, ask questions, and after you get a little bit of exposure, we'll go further. So you do see two windows. One that shows element that you select from element or group of elements that you select from the menu. but it is kind of a little piece in your hand that you are going to apply to your model. And then this white window is where you place things. So if you click once again to do this ethane molecule. Let me do something. So we do not need this right now, and we do not want to waste resources. Okay, and we do not go anywhere, we just stay here and goes view. And just practice a little patience, because there are several of us, it will take time. Oh, yeah, yes?
How do I transfer this to this?
No.
No?
I don't know how to do it. You're saving it, and there are options to copy and paste and then reproduce it as if you want to do a polymer.
Oh,
Uh-huh.
got it. Perfect.
Good. You probably should select building models with Gauss view, like this one.
Oh, okay.
I see a talent in your hands. Just try to click here in this space, and try to click on one of the hydrogens. Click here, and let me show something. If you select active atom here, click here, so it replaces, and then you do this like hydrocarbon. Did you build anything in this?
I already tried it.
Ah?
I already tried the second one.
Okay. Okay. Uh-huh. Very good. Very good. And you have probably noticed that there are some pre-made structures. Like Amir already tried the buckyball. There are some purines, furans, whatever you know from organic chemistry, and one can use them to build polymers. And there are some radical groups which you can use. So there are a couple of standard operations that you may want to get hands on. First, sometimes the model that you want doesn't fit into this idealized interatomic distances and bond angles. If you were trying to play with it, you saw that this software tries to use some standardized interatomic distances to have compensated, to put hydrogen on all uncompensated bonds, to put interatomic distances in a reasonable way, and do something that will look reasonable chemically and probably optimize it instantaneously. But sometimes you may need more than that. You may need some corrupt geometry with purpose. You may study reactions where positions, distances, angles are not as in stable structures. Sometimes you have oxidation states or photoexcited models where bonds and distances are not in the standardized way. And generally, if you are looking something that doesn't fit into this database of simplified things, you may want to put atoms on different distance, update the angle, and Another thing, if you are building polymer or you are deposit an adsorbate molecule on a surface, you may want to control the distance and angle and stuff like that. Right? So there are these three things: distance, angle, and dihedral angle, which are maybe the simplest thing that you can do for modification of your molecule. So we'll go over it very quickly, and you are very welcome to try it yourself. Just click on this three and see what happens, and then do something to your molecule. Another thing, we may want to save a model. Like, what if we will get power outage? What if something will not work? We may want to save the model and maybe send as a file through email or upload or download to other server and have it in hands later to process on a different computer. So saving, loading, and optimizing model. Please, what I'm telling you is not critically important. If you're playing and having fun, keep doing it. It's more important. When we will be working on saving, there will be an important question in which format to save. So probably I was already trying to say it. There are like several dozens of computer codes that basically do same things, and they just compete to each other. They're done with different people competing, telling my program is more optimal, my program is more optimal, and they save and load files in their preferred formats. So we may want to make sure that what we are doing, our models are universal and can be read by any code, or if it is in the wrong format, that we can convert it between codes. So we will go over it, but I'm giving you a little heads up that it is a thing to focus at. So I think the model that I have created is the simplest in the class. Everyone did something much more advanced with like hundreds of atoms and a lot of elements. So suppose I want to save this model. So I'm doing save, and I can call it ethane, right? And it tells me to call it with extension .com. But I can also save it, file, save, select different format. PDB is a protein database. It's not quite for material chemists and engineers, but it is quite standard, so it's okay to have it as a backup. And you do see that there are not very many options for saving, but one of the subjects in your sign-up list will be how to convert between different formats. Now, suppose I want to pull these two carbons apart from each other. What should I do? Probably click the modify the bond, click on first and second, and then it also wants so optimal distance is like 1.5 angstrom, but one can pull this thing and update it to the distance that you feel comfortable for your scientific problem. Like probably if you want to see a reaction how they will bounce backwards, you can put it a little further, or maybe you will design some more complicated thing. So you put the distance that you really want. Okay, and you can save maybe ethane elongated. Right now, in addition to distances, and we can elongate any distance, we can like put this hydrogen too far or too close. So at some point you may need it. if you do your scientific problem, if you do a research project. But in addition to this, sometimes one needs to change the angle. So right now, all angles in these hydrocarbons are corresponding to tetrahedral symmetry, right? But there will be situations when you need to depart from it. And if you click on these atoms, and there is a way to optimize, not optimize, but intentionally change this angle, and then later on you will funnel the structure into the code and see what happens. Right? So please, I will go over and see, but please try to play these things. So it is an important skill. I know it is very basic, but it will unleash your wings. Save, elongated, and it is also modified angle. There is a little broom here. Look on it. Symbol of a broomstick. It should work as optimization, but it is not true optimization. There are no computer codes being run. It just uses some databases for standardized interatomic distances and angles. So if you create something, if you draw your model atom by atom and then clean broom, it will do pre-optimization. You cannot count on it. It is you cannot publish anything did with this broom, but it will save effort of your CPU when you do real computation. But look here, if we align these carbons to be on one line, right? You see that these hydrogens are not matching. Probably because they are sterically repelling or some other reason. But maybe for purpose of your future computational project, you may want these hydrogens to align, right? So instead of moving each atom one by one, there is a way to realign this so-called dihedral angle. So there is a symbol here, and dihedral angle, it is like angle between two vectors that are separated in space, that do not share the origin. So we click first, second, third, and then if you put it 0, it will be aligned, right? Originally it was 60. So this parameter is called dihedral angle, and for some chemical problems it is important. And if you do catalysis or deposition or gas adsorption on surfaces, you may need this option to pre-made structure that fits your needs. So this tool works both for measuring this dihedral angle or distance, and also to modify it. So I'm going to walk around and see how happy or unhappy you are, and then we'll go further.
Do I press this to measure the angle?
Yes?
This one and this one?
For angle, you need to 3 atoms, right?
Yes. So this won't work on this. Oh yeah, this one.
Yeah, and if you pull it, it will start modifying your structure. And if you do not want the whole structure to be distorted. If you click those things, you can fix 2 and move 1. Just explore the options. How are you?
Good. So,
Is it showing something?
no.
No? Let me see. Huh. Interesting. Let's stop it completely. Three, 2, 8, 5, 7. 3, 2, 8, 5, 7. Once again. Okay, it's cute. Now let's do it once again. Goes view. Maybe by error something was touched that isn't expected to be touched.
I started doing that after I used the Boom tool.
Oh, okay. Maybe this your model was too large. So this broom is not like perfective. Oh, okay. So things look. It looks like it works. Did you try to save something?
Not yet.
Okay. Yeah, if you create something available and you're in the middle, you better try to save. Oh, of course you can do something more advanced. I'm just doing the same thing I did. Were you trying to change distances? It works?
It worked.
Ah, it does?
So, yeah. So I have to distance this one, angle this one. So
Okay.
total 4. Yeah. So I can, yeah.
Okay, very good.
It works.
Super.
We can do practice going through here.
I don't understand.
We can do practice going there.
Yes? Yes.
She makes this color.
But approach and task. Approach and task. Please, all of classmates are not competitors but colleagues, so it is very encouraged so that you talk to each other and help each other. Try to be friendly and we're not competing, we are trying to go over the barrier together.
So I know how I know that I did everything. So
Uh-huh.
I know how, and I also made it like this. But the problem is I deleted this. I don't
Oh.
know how I deleted it.
Do it once again. Do it once again.
I don't know how I
Just interesting.
I don't know if like how, but
So select the. Let me do it. So you select distance, 1, 2, and then there is like single bond, double bond, triple bond.
oh, I see.
But none. It's okay, but
I deleted it. I don't know how,
but
but
do not worry. Everything works.
Yeah, of course. But just one question.
Yes.
Can we optimize the structure using this software, or we can make sure the whole structure reach to the?
We will do it. I know that you want to do everything at once quickly, but of course it is belongs to our plans. Everything works as it should. So yeah, enjoying your structures.
Yes.
Okay, very good. Everything works?
Most ugly.
That's fine. So let's look on the list what we will need.
So we should choose the topic today.
You better select today. If you really want to decide, we can do it later. But if you select something that you like or you expect to like, it will be easier to plan. So we did a lot. We did so this one was done previous time. We did Gauss view, and we did building of atomic models, and we did the optimization of distances and angles. We also did the visualize by JMO. So I think it would be most reasonable. So we are not going to run actual calculations because it will take resources. What I suggest we, in the remaining time, we focus on the converting formats, and when we meet next Wednesday, we will do some launch some runs.
So I didn't get it. We should come and present each topic, each students, or what should we do with this?
I understand the question and I have clear answer. I just need to put words in the right order. I do not have exact date, but maybe like first or second Thursday, second Thursday of February, in about a month from beginning of the course. You will have a dedicated class time in the morning, when instead of me delivering a lecture, we will present the things, but it will be not myself, but everyone in class. So there are several subjects. We will chop them on very short, like 3, 4, 5 minutes long presentations, and you will just come one after another and briefly share your experience, how to like build models or how to open account on CCAST. Basically teaching those who were busy or disfocused or just strengthen the knowledge. And from previous years it seems optimal. Make sense? So give me signs if anyone needs immediate help with playing. No? I'm going to focus on converting formats. So what if LS minus LT. So when I was playing with models, I was creating several models, but can I open them in the JMO? Can I open them in the different software? So there is, and let me check if it is shown here. Yes. So it is partially covered in this thing. What if I want to convert this file from more ethane.pdb? So I'm not telling that it is wrong, but it is a little bit ugly format with too many excessive information. For analyzing it, sometimes it is sufficient only type of atom and coordinates. And here it tells details about coordinates, which atom connects to which one. So in addition to element, it labels them and then shows pairs that are connected. This is not wrong, but maybe too much, right?
And what is the zero color? It's,
Hmm?
there is a zero.
I don't know. I do not like this format, and I do not. I was surviving for many years without knowing it. If you learn it, please, or if you know it by now, please tell me, or please tell during this presentation. So there is a program that is intentionally designed to convert files between different formats. So if I type Babel minus input pdb ethane.pdb and then minus output xyz ethane. So we do not have file ethane xyz, but hopefully it will be created. So one molecule converted. Now I'm doing ls minus lt to see files, and you see this file was not there, but now it is here. And I'm going to more ethane.xyz. So it is in much more readable format that we used originally for the hydrogen molecule. So it takes crazy format and converts it into more readable. Right, so it's carbon, hydrogen, and then just shows the Cartesian projections. So this little example is not the whole story, because we converted only between two formats. But if you type, and I invite you to try to save something you did in Gauss-U in the PDB format, and then practice this Babel to convert it into XYZ, and I'll go around and see. But if one types Babel minus H, which means help, it gives a list of about 100 formats between different pieces of software. And if you were exposing to some molecular modeling, molecular dynamics, computational chemistry in the past, you may recognize one of these pieces of software or formats. So the typically three, maybe a few more letters code is a encodes format. If you go to the end, you will see that XYZ is among them. Right?
Can you show
Yes, of course, definitely. And then, so you give the name of the command, space, minus I, then no space, format of your input file, space, the name of your input file, space, minus output, and then format of your output file, space, and name of the file where you want to funnel your result. Is it large enough? I can change the font so it will be more visible. Let me try. Maybe it will be just No, this one doesn't work. Settings, configuration, size. Okay. I need to re-log into. Is it better?
Yeah, sure.
Okay.
So IPDB means that we want to
In-
read this file or convert this file.
So you convert this file. You convert this file into this file.
So output is XYZ, right?
Yes. And formats like this are very typical in Linux. So you have commands that have some arguments to
The second part should be output.
yes, like I for input, O for output.
Okay.
And then since there is about 100 types of input files and 100 types of output files, it's about 10,000 options to run this command, right?
So all these files are coordinate files?
All types, let me show it once again. All types listed here are coordinate files, right?
So how can I check these files? Like what are them?
Wait. Depending on your needs for your research, you use this or that piece of software. Like in this class, we will cover like maybe 2-3 pieces of software, but there are like 100. And depending on what you need and what is the format of the coordinates that is being used by software that you use, you select it as either input or output. So this Babel is like a translator between different formats of coordinate files. In addition, there are several powerful tools, several powerful options in this command, but we do not have time to focus on it. It can like chop a big model with several molecules on individual molecules, or it can combine several molecules into one model. So it has some versatile options. But the basic goal of this software is just to convert from one format to another one. So I invite you to save the model that you did draw with Gauss view. Huh?
It's showing error.
I'll approach and check. If you were, where's your, wait, check. You are not doing a thing, you were doing something more complicated, right? So,
No, I saved it as ethane. First of
Oh,
all, I did
okay.
ethane, then I overwrote it.
okay, and it's still, oh, okay, Control C. Let's do once again. What happens? There should be space here. And space here. Okay, and now do have it's something different. It's not just 4 atoms.
I chose multiple atoms.
Here in your source, it's also very few atoms. Well, you can check what happened and do it once again with Gauss view, But now for this molecule, we can open it with GMO. And you can try to repeat and build bigger model.
So I drew two things,
Okay.
and I have it saved. But
Okay.
I'm still not entirely up on how I'm supposed to enter commands.
File, save. I'm trying to avoid Gaussian format because it's proprietary and they are very they
Enforce it.
even in the Babel psychosu.pdb or pdb, and now we do Babel minus I pdb psychosu pdb minus O xyz psychosu.xyz. So it's overall.
Okay.
And one can check. If it will give the same model, just check that you draw it in one software and then read it in another one. Well, it's not a thing, it's something more complicated, right? I'm not sufficiently chemist to call it complicated. And I do not want to use, I better use PDB because Gaussian is proprietary. Save, okay. LS minus LT to see what I have. No, we are not. Which one?
First one.
Okay. Complicated. More complicated PDB. It's really complicated.
Yeah.
And now we do. Babel minus I PDB. Complicated PDB. Minus output XYZ. Complicated XYZ. XYZ. LS minus OT. New file appeared. More complicated XYZ. It's a little simpler. And here we can file open. Okay.
So what is LT minus LS minus LT?
Oh, just list arranged by the time it was created. Okay. most recent to the top, or the oldest last, just to check what was created recently. Thank you. I'll maybe with you very shortly. Okay. So we let's do here ls minus lt, ls minus lt. Complicated.xyz, okay. Where it is? So it is what you created, right?
Yeah.
Okay, so you created in one software and then read in another one.
Okay.
I know it's not a big scientific discovery, but you are just getting hands-on.
No, like I'm wondering why it's not popping up in the coordinate like his.
You mean? Oh, sorry. This?
Oh, okay.
So I converted converted from PDB to XYZ, and then I open using JMO.
Super.
Then
That's
now
great.
I can view and then.
Excellent. Yeah.
Is that?
Yep.
is that
Yep.
okay?
Yep. Everything works. Good. Everything works. Very good. You're helping each other. Everything works.
No, there's
No.
always have some
Okay, let me.
errors.
So, file, save. Well, it's not ethane. It's 6, 7, 8, 9, 10. So it's let's call it like C10. C10, and Gaussian is proprietary. Let's use PDB. C10 PDB. PDB. Save. Now look here. PWD. Young Chow.
Yeah, so
File,
this is
just
all-
save.
Oh, you see what's going wrong.
this is my last name and Yang is my first name.
It should no, it's Young Chow. PGB. Let's check. C10 PDB. More C10 PDB. And now we converted Babel minus IPGB minus output XYZ C10 XYZ. C10 XYZ. Okay, and now you can open it with JMO. SH C10 XYZ. Okay.
Okay, thank you.
Yep, no problem. Everything works? Okay. So let's check where we are and if you want to do anything else today, or it is sufficient. So I think it will be sufficient for today. I'll sit here, answer questions, but you may need energy for your other activities and have some rest. So I can briefly go over things. Probably the next vital skill, they all are important, but next one will be uploading and downloading. It's very simple, and we have time for it. I just do not want to overload you with new information. Those of you who already run things on a CCast can just, probably one of you can select it and teach everyone else how you did it, like which website you went, how did you feel, right? We will do some running of Gaussian software. Some enthusiasts, especially those who really want to install something on your personal computers, you may look onto this 12 and 13. Especially 12. 12 is free. 13 is free for trial first 2 weeks, and then it is commercial. But I do have a license which works on a PC with the memory stick. If someone interested, or if you have from other sources, these two pieces of software do building of models in competitive way. So Gaussian is considered as a gold standard, but those are competitors. Avogadro is a little bit worse because it is free, and Gaussian is you can purchase it for your personal computer, but it is and they're not cheap. We are using it on a shared facility just to be economic. It's like a couple thousand per license, or maybe more. And HyperChem is not expensive, and it was really top software on the globe like 20 years ago. Now it's a little obsolete, but still it is very good thing to test little models and run molecular dynamics on PC for small models for short time. If you want to design your research plan and make some quick tests before you upload things and do massive computation, this is quite good. So some of enthusiasts may select it. Also, if your research interests are focused on amorphous materials, on solvents, gases, small molecules, you need to use your chemical intuition and draw models, or import it from like colleagues, or from this databases with some like rings and standard radicals. But if your research interests are associated with crystals, in some sense you are a lucky person. For regular periodic crystals, there is a characterization technique based on X-ray diffractometry, right? When you just put X-ray, change angle, take detector, and then make Fourier transform, and based on diffraction of X-rays, one can reconstruct position of each atom in the crystal lattice. So if you work with crystals, you can forget about anything we did here. And you just need to import so-called .cif crystallographic information file data from your X-ray crystallographer friend, or from a paper, or from COD, crystallography open database, and then either read it with this Vesta software, or there are ways to convert it with Bible and other things into, so that it can be read by Gauss View or other pieces of software. So though if right now there is no time for me to get more closely acquainted with research interest of each of one in the class, but you may look inside yourself and decide if any of you is interested in crystallography, you may select this subject and expand on it. So it's still good part of the class, but it is a little bit different mindset if you want to target crystals. Okay. So I think with that, formal part of the class is dismissed, and I'm going to show a couple of slides which will be more entertaining, and then I will give an assignment to myself that I will try to complete here with these tools, and you may either depart, because there will be nothing new, or you may see and watch me or discuss some questions. So class is finished. I'm going to look on the chemical reaction of deposition of this diazonium salt on a silicon surface, and build a model that will allow to. There was already a model to describe it, but it was a little too big. There were many layers of crystalline silicon, but in this molecule one can see a reaction that this nitrogen departs and the anion of bromine picks hydrogen from surface. Then there is one unsaturated silicon, and it tries to pull this aryl ring and absorb it on a surface. I just do it assignment for myself for fun, and I will.
Is it reactive for
Yes. No. It's ab initio molecular dynamics with like DFT based. So it is a little more precise than the reactive force field. So, looking forward to see you tomorrow at 11. I will finish the recording and share it if you want to focus on one or other part of the meeting.
Just want to make sure we're completely clear.
Just a second. I want to finish it so that it gets done processing.